called the discriminant. And the discriminant ready? Yeah. Oh, yeah. The discriminant is the thing that's underneath the root sign when we do the quadratic formula. So remember the quadratic formula that we learned yesterday? There's a whole bunch of stuff underneath that root sign. We actually call that the discriminant. So, let me show you. That's a mic. Just record a little better. That's fun. The discriminant is the thing underneath the root sign. That's literally all it is. So, do you remember what's written underneath the root sign? What is it, Todd? B squared minus 4ac. That's your discriminant. It's the thing underneath the root sign. Did you write the thing under the root sign? That's fine. It's b squared minus 4ac. That's from your quadratic formula that we learned yesterday. If you weren't here yesterday, that's all right. We actually already did some of this lesson yesterday. When we're factoring things, what are we actually finding? Smith. X what? The x-intercepts. So what happens if you did the quadratic formula and you got a negative underneath the root sign?
No real roots.
No real roots. What does that mean? No x-intercepts. So if the discriminant is negative, you know that there's no answer. So before you even go solve questions, you can check to see if there's an answer at all. The discriminant would tell you that. What we usually see is that the discriminant is a positive number that's greater than 0. And then what happened to our answer? How many did we get? We had two answers. We had the positive version and we had the negative version. What happens if it's exactly 0? Square root of 0 is 0. Plussing or minusing 0 is not going to make a difference, is it? So how many answers would you get? Just one. And that's the whole idea of the discriminant. It'll tell you whether you have 2 solutions, 1 solution, or 0 solutions. And solutions are x-intercepts. Correct? So if we graphed it, it would be x-intercept. Exactly. 2 solutions mean you have 2 x-intercepts. 1 solution means 1 x-intercept. No, the discriminant tells you how many answers there will be. It doesn't tell you the answer. So if the question said how many solutions are there to this quadratic, you would only need to know the discriminant. Rather than actually factoring and spending 10 minutes doing all the work to figure out the answers, you could just check and be like, oh yeah, 2. That's the answer. There's 2 solutions. You're going to see that come up probably as multiple choice on your unit test. There's a couple questions on this lesson. Not many, because it's pretty easy. But there's a couple, and they should be pretty quick, and they should be something just like that. So, that's more of an information page. This is what we just literally talked about. Remember, you can't square root the negative. This one, this sums up what we just said. So, if the discriminant is less than 0, or it's negative, you have 0 solutions. I'm going to write up here that solutions are x-intercepts. They're also known as roots. They're also known as zeros. Those are all terms that could be kind of intermingled. Aaron. The answer. So when you plug in the B, the A, and the C value, if it's less than 0, you have no solutions. When you plug those numbers in, if it's equal to exactly 0, you get 1 solution. And if it's greater than 0, you get 2 solutions. London. That's a good question. You can't, because it's a quadratic. So quadratics will only ever have x squared as the highest term, which means it can only have one loop. It can only turn once. So in one turn, it's only possible to cross the x-intercept twice. This is a nice little diagram to see what it looks like. The first one, that's what no real roots would look like. The graph never touches the x-intercept, so there's zero solutions. There's no real roots. This one's the one that usually messes people up the most. One real root, what it looks like as a graph. It just touches it, yeah. Right there it comes down, it just touches the x-intercept and then it goes back up right at that point. So the minimum point is right there. The picture? Yeah, it helps. It's right in there. And yep. And if there's two solutions or the discriminant is greater than 0, you get a picture that looks somewhat like that. It could be flipped, moved to the side. Or you could do lots of crazy things, but you know you're going to have two x-intercepts. And that's all that really matters. Let's try a question. Use the discriminant to determine the number of solutions for each quadratic. So for this first one, what's the discriminant going to be? B squared minus 4ac. If you're wondering where that comes from, the discriminant is what's underneath the square root sign in your quadratic formula. That's where I'm getting those numbers and letters from. Soccer.
Does that negative go with the 8?
The negative right here is stuck with the 4. So you can either do it as
like the b squared would still be negative 8 squared.
That's a good question also. Use brackets. So we're going to do this question right now. The b value is negative 8, so you do negative 8 in brackets and then square it. And that'll make it positive. Because a negative squared is positive. Minus 4 times 5 times 6. 4 times 5 times 6. And you should get 64 minus 120, which is negative 56. If it's a negative discriminant, what is Jacob? No solutions. We write no real roots if it's a word problem. No real roots would be your answer to A. Yeah, or if it depends on the question. If it said, like, how many solutions are there, then the answer would be 0. But if it was a question that's what's the factor, no real roots would be the answer. Because there is no factor.
That's the only thing we really have to remember.
B squared minus 4ac. If you're being asked anything about the discriminant, that's all you need to know. In my opinion, all you need to remember is the quadratic formula, and then you can always see right there that the discriminant is b squared minus 4ac. Okay, try B and C on your own. Okay, I'll show you. So, B, I did b squared minus 4ac. B squared is 4, that's where that 4 comes from, minus 4 times A times C. C is negative 3. Make sure you put your negatives in your brackets, because that's going to be important. When you solve 4 times 1 times negative 3, you should get it's equal to negative 12. Minusing a negative 12 makes it positive. That's how you get positive 16 as your discriminant. You don't square root it. You just find the discriminant. So how many solutions do you have if your answer is positive? 2 solutions. S-O-L-N. Solutions. That's just how I'm going to write it. If you're ever wondering, I'm lazy. The second one, b squared, negative 2 squared is 4, minus 4ac, a and c are both just 1, so that's nice. 4 times 1 times 1 is just 4. 4 minus 4 is 0. Josh, you pay. If you have 0 as your discriminant, how many solutions do you get? 1. That easy. Well, this would be an easy lesson. I didn't lie today, right? Doctor.
If your discriminant was 1, that means it has 2 solutions.
You got it.
I did it, but I put in like 4 times 1 times negative 3. I got negative 12. Am I just doing it wrong?
4 times 1 times negative 3 is negative 12, but then you're minusing negative 12.
Which is okay.
Minusing negative 12 is like, yeah, exactly.
But then we'll
Think of it as, what's the best way I can go? Somebody described it best with money. It was like, the negative value would be me owing money, but then if I paid off my debt with a negative on the negative, it's actually gaining money. If somebody gave you money to pay off your debt. This is the weirdest explanation ever, but it was awesome. The one that I don't understand is dividing by negative. A negative divided by negative is a positive. Nobody's ever explained that nicely to me. Like, there's no good analogy. It's just is. It's just positive, and nobody's ever been able to explain it. Yeah. Like, what's a good analogy for that? To why negatives cancel out when you divide. Like, I've never heard a good explanation for that.
Negative sign. Yeah, make it positive.
That's fair. And they just switch and connect to make it positive. That's awesome. I'm gonna show you this. And they just turn positive. Hey, Mr.
Sorry to interrupt you. May I give you some books?
Yep. You just set right there.
They're super heavy.
Awesome. Thank you.
Thank you.
Okay, a higher level thinking question for discriminants is going to be one like this, where it says determine the values of k for which the equation has 2 real roots. Remember, we want to underline our important information. K is actually highlighted for us, so that's pretty nice. It's not? Oh yeah, black and white doesn't highlight well. Underline your k and underline 2 real roots. If you have 2 real roots, what does that tell you? It has to be greater than 0. That's close. They want values, not value. So you need to tell all the values of k. That would make it greater than 0. So it's going to be a greater than or a less than type question. Here's the trick. 2 real roots gives you a formula. The formula is b squared minus 4ac is greater than 0. That's what 2 real roots means. They gave you a formula by saying 2 real roots greater than, or there is 2 real roots. Now, use your formula. Sub in everything you know. What is b? Negative 5, and it's in brackets, minus 4, what's a? Times 3, what's c? No, it's k. C is k. So you just put k.
I have a question. Why did you have the other ones when it was?
We've never had that. C is a constant number. It's not a variable. Right? Because what does the question ask you? Solve for values of k that would give you 2 real roots. It's asking what c values would work. A lot of them. And if you solve this, it'll tell you. What is negative 5 squared? 25. Minus, what's 4 times 3? Minus 12k is greater than 0. London.
Oh, okay, I have to be greater than 0 unless.
Well, yeah, just wait. We're gonna work through it. We have another question.
Well, we changed another one to positive, so why did we change that one?
That was minusing a negative. We don't have a negative.
Oh.
Yeah. K, now isolate for K. Subtract 25 from both sides. Right? Subtract 25. Subtract 25. And you have negative 12K is greater than negative 25.
And then when you divide by a negative, don't you flip the sign?
Yeah.
Well, what is
Now, how do we get rid of this negative 12 on the K? Divide both sides by negative 12. And Amber spoiled the fun for me. When you divide by a negative, or you multiply by a negative, you need to change your sign. So it's K is less than, and 25 divided by 12 isn't a nice simplification, so just leave it as 25 over 12. So K has to be bigger than 25 over 12. That would be your answer. Sorry, K is less than 25 over 12. That means as long as K is smaller than that number, it would give you two real roots. Less than. When you divide by a negative, you switch the sign. Whenever something like that happens, this is just a math trick, and you're not sure what the rules are, I like to just plug in numbers and test them. So like when I don't remember if exponent laws work, just use numbers and see if it actually works out. So if you did negative 3 is less than 2, that's true. You've divided both sides by negative 1. 3 is less than negative 2. That doesn't make sense anymore. So you have to switch the sign. Yeah. So K is less than or equal to 25 over 12. That's your answer. Question?
Why is this like the half triangle thing is the big end is pointing to the negative 12K?
Why does it change?
Yeah, why is
Because we divided by a negative. So anytime you divide or multiply by a negative, it'll switch that middle sign. And if you're ever wondering why, just test it yourself. Negative 3 is less than 2. That's true, right? If you multiply both sides by negative 1, it would become 3 is less than negative 2, and that's not true anymore. So you have to change the sign to make it true.
And that's only when you divide by a negative?
Exactly. Or multiply. Anytime you divide or multiply by a negative, it changes the sign. Other than that, you just treat less than or greater than signs the exact same as an equal sign. You just move things to the other side, just like normal. How are you feeling about the discriminant? Not bad, eh? Okay. I believe that's it. Oh, no. Fill this in. On your own. Good question. Greater than, and then less than. The way to know it is, did you ever do the alligator?
Yeah, the alligator wants to eat the bigger one.
Yeah. The alligator eats the bigger side. You've never done that? The alligator always eats the bigger side. So this side must be greater than this side because the alligator wants to eat it. That's legitimately how I learned it.
Yeah.
And if you flip it, it's less than. So it would be, this number would be, if you switched your alligator around, your alligator was like this.
Not finish the alligator.
This number is less than this number because the alligator wants to eat the one on the right.
Finish drawing the alligator.
Finish showing the alligator? Yeah. You got blue light. Nail it.
Yeah, that's what I was.
Hello,